now on, I might be talking a little bit more about CNC milling, which is basically a drill that is computer controlled that goes through a solid plate of, say, aluminum or plastic or anything, so that it makes a desired shape that you design in SolidWorks. And usually the cheapest parts that you can design are 2.5 dimensional parts, which means that once you get a drill and you move it around, as long as you have the plate that is of the right thickness, you will get the part that you want. So there are no difficult features to design or anything and the such. And when it comes to these NeveRest motors, something that is really good for those that is really good about these is they actually have 6 tap holes around the side. So these are all M3 tap holes, of which you can use to help yourself mount these motors. So I'm going to show you how to design a plate that would act as a motor holder for these NeveRest motors. So first I want to, say, open a TETRIX part, say, as I did before, a random channel, and use this to define the assembly. And then I also want to insert a NeveRest motor as well, like this. Say I want to use this motor to turn something that is on this plane. That would mean that I would want this motor to be parallel to this one. Okay, let's go around this way. And then right now, I'm going to try design something, a plate actually, that would help me mount this motor onto this channel. So I'm going to go to insert component. I'm going to insert a new part on this plane, and since I'm making a part, I want to make a square like this. And on the square, before that, let's try looking at the shape that is on this NeveRest motor. So I would start off by converting the entities. Convert entities features help you change the different entities that are on TETRIX that help you on any part, so that it will help you design things with ease. Yes. Now the part is, now we designed this, let's try to see what the hole patterns are like. As you can see, the inside diameter for this is 31 millimeters, and the outside dimension is 37. So 31 and 37. So if you want to make something, if you want to make a part that safely acts as a motor holder for this, we would basically need to make these shapes. So say I want to get this motor dead center of this part. I'm going to once again start off by inserting a new part on this plane, and I'm going to make it like this. I'm going to insert a construction line right through here, and make sure that these two intersect. So let's make a dot at the center of this and make these two coincidence. Yes. And let's make this around 40 millimeters long. This, say, 60. Actually, might have to become 70. And then here, what we can do is we're going to make a circle that is for construction. Actually, around 3 circles. This circle will be for construction. The smaller inside one will be just a circle, and another one will be just another circle. This will be 37 millimeters. This will be 31. And the inside one will be, I don't remember what this one was. 12.50, so 25 mils. And I'm going to draw another circle right here, so that this can act as the circle that lets in the bolts as you're trying to bolt it in. A note: when you are drilling holes to fit on a plate to be CNC milled, you want to make it 0.2 millimeters larger so that it's easier to put in your bolt. So I'm going to make this circle 3.2 millimeters in diameter, and I'm going to do a circular sketch pattern across this. Actually, no, I'm going to do a circular sketch pattern across this dot. And the entity to pattern will be this. And this will be the circle. And then I want to make 12 holes actually. 12 holes. Equal spacing, yes. And now I have this pattern. Let's say I want this to be, wait, I have to still edit the sketch, so I want these two places to at least have some distance from each other, so say 25 mils. Let's move that dot right here. Let's first start off by extruding this. That has to be 80. Yes, it fits. And let's start by extruding this part. And then also this part. 3 millimeters because we may be using a 3T bolt, and then let's make these two parts concentric. I want to get out, yes, concentric like this, and you'll see that these parts fit. But then something else that might actually be really good to put in this design is you want to face mill a part, which means the total thickness of the thickness in different parts of this plate will be different. You'll see very soon what I'm talking about. I want to edit this component, and on this sketch I want to do an extruded cut. Of this place, and I want this to be just 1 millimeter thick, and I want it to go inside, so other direction like this. And also remember, this is as well another hole, so you will want this to be 37.2 mils like this. And if we connect this here, when you're actually assembling this gearbox will go really nicely into this plate, which means it's going to be much easier to align the parts to be concentric, and also to put them in the positions that you desire them to be at. So let's make these to be coincidence like this. And when you're editing it, you can easily rotate this for it to go and take the desired place you want it to take. Like this. And say you want the circle to be here. Make them concentric. And now you have a really good motor holder. And probably this slab is going to be much cheaper than the ones you get from Pittsco, but also it will be much more versatile and really stronger. And if you want to connect this to this part, it's very simple to design it using the top-down approach. Let's add a sketch. Let's add a sketch to this plane. And then use these 4 circles, convert entities. So, not the faces, wrong click, this circle, that circle, that circle, and this circle. And before doing anything else, let's add a sketch to this part so that this may become a better part. Make these 2 collinear, make these 2 collinear. Make this distance say 60. And we want to extrude it 3 mils the other direction. And then we're going to extrude the holes. These 4 holes like this. And this is a very crude but also working motor holder for your part. And also, as you know, since sharp edges are dangerous, when you want to print this out, when you want to carve it out on a CNC machine, you will want to add different fillets, not linear pattern fillets. Make the diameter, I guess, just 1 mil. And then add those fillets to these sides, just for safety, for the person making it and for the person who will be using it. Click, click, and yes. Oh, mistake. Let's get rid of that. Delete the loop like this. That got deleted in the way, so let's add that as a final touch. And now you have a piece of aluminum that you can make on your or in your local manufacturing places CNC machine. This I have figured out was a very efficient method of connecting motors to any different chassis, or actually having a design where the motor turns out to be a part of the final mechanism that you make. And that is something that I will be talking more about in the later videos. But you'll soon figure out that it's very easy to design parts to be CNC milled on SolidWorks, and usually it's a very good design approach to take, because those parts are usually more versatile than the ones that you get from Pittsco, because these ones you can actually design them according to your needs. So thank you for watching today, and in the later videos I will come up with other applications where we can use SolidWorks to design sheet metal parts. Thank you very much.